Okay, let's do a trig modeling problem. This type of question, they typically give you the full equation. So it's very important that you know how to fully graph and understand a graph question. And then the last step is just to connect that information to the real world description in the question. Okay, so let's do an example together. Here it is. Okay, so again here, this is a type of question where they describe things that are happening, but they give you the full equation. The harder type of question is where you actually have to come up with the equation yourself. Okay, so that's the easy part. But still, right, the equation given is not so simple. So we have to decipher this information and match with the situation carefully. Okay, so let's take a look at this. We're looking at a water level that goes up and down depending on the time of the day. It's quite dramatic because the amplitude here is 7, meaning, okay, it'll go up to as high as 7 and go as low as -7, okay? And 0, we're assuming it's sea level. Okay, and there's also that -2.5 represents a shift. So we're gonna start at 2.5 and draw a sine curve, like so. So this is our graph, and it has a maximum of 7, minimum of -7, okay? Okay, so, right, note that here, why does it start here? Okay, a very simple answer would be if you replace t with 2.5, right? So h at 2.5, sine 30, you get 2.5 minus 2.5 is 0. So you get height is 0. So it makes sense. And when time is 2.5, right, the height is 0. So we're starting from here and it goes up and down. Okay. All right. The next really important thing is the period. So in fact, we can answer A already. You can see that it's 7 meters. And then it's -7 meters. -7 meters here just represents 7 meters below sea level, okay? And what time do the high tide and low tide occur? Okay, so we need to find out what is that time there and what is that time there. And for that, we need the full period, okay? And the period, how long it takes to complete one cycle, is 360 degrees divided by 30, which is 12 hours. That makes sense, right? 12. So this is going to be 12 plus 2.5, 14.5. This is going to be 2.5 plus half of 12, which is 6, right? So 6, 8.5. And then half of 6 is 3, so this is 5.5. And you add another 3.5, another 3 here is 11.5, okay? So 5.5 is actually 5:30 a.m., right? Because this represents time, when time is 0, so the graph actually goes like this, right? At midnight, the height is like here somewhere. So this is 5:30 a.m. and this is 11:30 a.m. So another 6 hours after that, still a.m., right? And then the cycle repeats. Okay, so this is going to be plus 3 of that. So that's going to be 17.5, right? That's, if you subtract 12 there, it's 5:30 p.m. Okay. And then if you add a 12 to 14.5, that's 26.5, okay? Subtract 3 is going to be 23.5. That is going to be almost 24, right? So almost 24 hours. That's going to be 11:30 p.m. Okay. So at these two times, we get high tide. At these two times, right, we get low tide here and here. Okay, so that's what we just answered B, right? Lastly, okay, we need to now write this as a cosine function. So if it's a cosine function, we're starting here, So the shift is this. Okay, so everything else is exactly the same. So 7 cosine, the period is still the same. So it's still 30 here, but the shift is gonna be different. Instead of 2.5, it's 5.5. So we just do t minus 5.5, right? Cosine curve starts from the top and goes to the bottom like that. That's one cycle, right? Okay, so that's an example of modeling waves, right? Modeling with sine and cosine curve, but we're given the full equation to just match that information to the equation. That's it for this one. I'll see you in the next.